Welcome to this video. So in this video we are going to look at the Stanford Math Tournament problem, which is this integral from negative pi over 2 to positive pi over 2 of this function. So this one is not an odd function. So because it's not an odd function, our integral is not going to evaluate to 0, right? So we have to find a way to evaluate this. So let's start off by writing what cosecant square of x is. So cosecant square of x, this is the same as 1 over sine square of x, right? And secant square of x is the same as 1 all over cosine square of x. So let's plug this into our integral and try to simplify our integral. So negative pi over 2 to positive pi over 2 of sine of x plus cosine of x all over 1 over sine square of x times 1 over cosine square of x dx. So I'm going to multiply the numerator and the denominator of this integral by sine square of x, cosine square of x. So let's do that and see. So pi over 2 to positive pi over 2 of, so sine square of x, cosine square of x. Then I'm going to multiply around by the numerator, which is sine of x plus the cosine of x. All this one, you multiply the same. The denominator was simplified to 1, but I'm just writing it out for clarity, which is sine square of x here all over the cosine square of x like this dx, right? This is equal to, so now I is going to be equal to what? So you see that some terms will cancel, this one will cancel this, and this will cancel that, right? And the numerator is just left with so we now multiply in, we are going to have the sine to the third power of x cosine square of x, then this one times that is going to give you sine square of x times the cosine to the third power of x dx. Now we are going to split this one into two different integrals, the integral from negative pi over 2 to positive pi over 2 of sine to the third power of x cosine square of x dx, plus the integral from negative pi over 2 to positive pi over 2 of sine square of x cosine to the third power of x dx. Cool. So let's call this one integral 1 and integral 2. So let's look at the integral 1. So we have I to be equal to, so I1 here is going to be equal to the integral from negative pi over 2 to positive pi over 2. So I can do this one in a different color. So let's do this one in a different color. So I1 is the integral from negative pi over 2 to positive pi over 2 of sine. So sine cube of x, I'm going to write that one as sine square of x cosine square of x here, then I'll multiply this sine of x by the dx here. I'm just bringing one of the sine of x to the differential operator, and this one is equals to the integral from negative pi over 2 to positive pi over 2 of sine square x from the Pythagorean identities is 1 minus the cosine square of x times cosine square of x times sine of x dx. And this integral is going to evaluate to 0. Why? Because we are going to do a u sub. We can let u to be equal to the cosine of x. When we do that, let's find out what the change in limits. When x is negative pi over 2, we have u to be equal to the cosine of negative pi over 2, which is 0. When x is positive pi over 2, u is going to be the cosine of positive pi over 2, and that is equal to 0 as well. So our integral here is really going to be, and du here is going to be negative sine of x dx. So that implies a negative du is going to be sine of x dx. So in place of sine of x dx, I can replace that with du, but the limits don't change. So I1 is really the integral from 0 to 0 of 1 minus u squared times u squared, and then du. There's negative here. But because the limits of integration do not change, this integral is going to evaluate to 0. So this integral is equal to 0. Now let's do the I2 and see whether we get the same value. I2 is the integral from negative pi over 2 to positive pi over 2 of sine square x and cosine cube of x. So it's the cosine cube of x and sine square of x dx. So here is going to be the integral from negative pi over 2 to positive pi over 2 of cosine square of x sine square of x times cosine of x dx. And I2 is the integral from negative pi over 2 to positive pi over 2 cosine square x. I can write as 1 minus sine square x from the Pythagorean identities times sine square of x times cosine of x dx. And I'm going to do a u sub here, just like what I did in I1. You can let u to be equal to sine of x here. So that means that du is going to be cosine of x dx. So in place of cosine of x dx, I can replace with du, and then the change in limits. When x is negative pi over 2, u is going to be sine of negative pi over 2. Sine is an odd function, so the sine of a negative angle is the negative of the sine of the positive angle. So that is negative sine pi, which is 1. When x is positive pi over 2, that is the upper limit, u is going to be sine of pi over 2. That is sine 90, that is positive 1. So our integral here, I2, is going to be the integral from negative 1 to positive 1 of 1 minus u squared, because sine of x is u times u squared, and cosine of x dx is du. So this one will not actually evaluate to 0 after all. So negative 1 to 1 of u squared minus u raised to the power 4 du. And that is just multiply in with this guy. Cool. So now I2 is going to be, you can now integrate, this is 1/3 u cubed minus 1 over 5 u to the power 5. Yeah, integrating that from negative 1 to 1. So I2 is 1/3 1 cubed minus 1/5 1 raised to the power 5. This is the upper limit minus 1/3 negative 1 cubed minus 1/5 negative 1 to the power 5. That is the lower limit. So I2 is, this is 1/3 minus 1/5 minus, this is negative 1/3, and this is positive 1 over 5, because this is negative 1 times negative here. So we are opening that, that is going to give you 1 over 3 plus 1 over 3, 2 over 3, and then minus 1 over 5 minus 1 over 5, that is 2 over 5. LCM is 15. LCM is 15, and then that's going to be 2. That is 5, that is 10, minus this one is 3 times 2, that is 6, and that is 4 over 15. So that is the value of the second integral. So this integral evaluates to 4 over 15. This one evaluates to 4 over 15. So the integral is split into two integrals, I1 and I2. I1 is evaluating to 0 and I2 is evaluating to 4 over 15. So that the answer to our integral is just the value of the second one. So I is I1 plus I2, and that is equals to 0 plus 4 over 15, and that equals to 4 over 15. Therefore, if we integrate from negative pi over 2 to positive pi over 2 of sine of x plus cosine of x all over cosecant square of x times the secant square of x dx. This one evaluates to 4 over 15. This is the value of our beautiful integral. So if you find this one helpful, make sure to give me a thumbs up, subscribe to my channel, comment down below, and let me know if you have a shorter version of answering this question. I thank you so much for watching this video, and I will see you in the next one. Bye bye.